Welcome to our Scientastic class. I'm teacher Bregeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together. Let's have a warm-up activity. Get a cube of ice and then put it on a plate. Let's sit there for 20 minutes.
A few moments later.
What happened to the ice on the plate? Yes, the ice melts. Can you explain what happens to the molecules of the ice as it turns into water? What causes this change? Alright, the molecules of the ice expand together with the spaces between each molecules, turning the ice into water. The absorption of heat from the surroundings causes it to happen. Heat transfer happens around us all the time. Although we do not see how this process takes place, its effects are evident. In fact, we rely on this effect every day in many activities that we do. People often interchange the use of the terms heat and temperature in their daily conversation. We also think that heat and temperature are just the same. But for physicists, heat and temperature are two different concepts, and we are going to learn that today. Heat is a form of energy that is very familiar to us. In physical science, heat is important to all aspects of life, especially plants and mammals. We depend on heat produced by chemical reaction of food during digestion to keep our bodies warm. The Earth's atmosphere needs heat to make air move and to create weather patterns. Energy is transferred between substances as heat. It takes place between objects and places of different temperatures. The energy transferred as heat tends to move from an object at a higher temperature to an object at a lower temperature. So energy will travel voluntarily from an object at a higher temperature to one at lower temperature and not the other way around. Heat is measured in calorie and in joule, since this is a form of energy. Remember, heat always flows from hot to cold. Heat exists as energy in transit, and it is not contained in an object. The energy that is actually contained in an object due to the motion of its particle is called thermal energy. The thermal energy of an object is changed if heat is transferred to it or transferred from it. Since the amount of heat transferred relates to the amount of change in thermal energy, therefore, heat is also used to measure of the thermal energy transferred. Recall that matter, solid, liquid, and gas is made up of continuously moving molecules or atoms. Due to its random motion, the atoms or molecules in a matter have kinetic energy. Thus, they are moving. Thermal energy is the total kinetic energy of all particles in a substance, and it is measured in joules. I have here a picture of cold orange juice and hot coffee. Orange juice has a low temperature particles and has a low average kinetic energy, while hot coffee has a high temperature particles and has a high average kinetic energy. The hot coffee has a higher temperature and its particles are moving faster, so it has a greater average kinetic energy. Temperature is dependent on the average kinetic energy. For example, when you touch a hot object, you feel the sensation of pain. What causes it? It's because the pain is related to the speed of particles in hot object. This leads to the definition of temperature, which is proportional to the average kinetic energy of particles in a substance. In short, heat is energy, while temperature is the measurement of that energy.
Temperature can be measured in degrees Celsius, Fahrenheit, and Kelvin. Thermometer is a device used to measure the temperature through the expansion or contraction of a liquid, normally mercury or colored alcohol, in a glass tube with a scale. What is the difference between thermal energy and temperature? For example, a glass of water can have the same temperature as the swimming pool, but the water in the swimming pool has much more thermal energy because it contains more water molecules. Let's have a short activity. Which has more thermal energy? Bowl of soup or a pot of soup? Answer: pot of soup. House cat or a tiger? Answer: tiger. Small balloon or large balloon? Answer: large balloon. I have here a table that shows the differences between temperature, thermal energy, and heat.
This is all for today, class. See you on our next episode. Bye!